Okay, we're going to look at ionic bonds and who reacts with whom. So there are three types of chemical bonds: ionic bonds, covalent bonds, and hydrogen bonds. We're really going to focus on these top two, ionic and covalent. An ionic bond is like chlorine and sodium. You have a metal from the left side of the periodic table bonding with a nonmetal from the right side of the periodic table. These are incredibly strong bonds. Covalent bonds are usually from both on the right side of the table. They tend to share electrons. They're a little bit easier to break those bonds than an ionic bond. So, as we were talking about, ionic bonds, when I have a metal from the left side bonding with a nonmetal from the right side, these are really strong interactions because they have to do with the fact that they are stealing electrons or giving away electrons. So they get a charge because that outermost shell, that valence electron shell, it really wants to be full. It wants to get to that noble gas state of 8 electrons in its outermost shell. So the basic rule is if I have 4 or less than 4, I'm going to give them away because think about it, it's easier to pull if I have 3 electrons, is it easier to pull in 5 people or to kick 3 out? Well, it's easier to kick 3 out. If I have 5 electrons, it's much easier to pull 3 additional electrons in than to kick 5 out. So the general rule is if it's less, and we're not going to really go through 4s because that's a whole different carbon chemistry and that's really complicated. So we're just going to worry about if we're less than 4, we give them away. If we're more than 4, we take them in. If we have 8, we're noble and we don't need anything. Again, remembering that the groups tend to have trends. The families have characteristics that are the same. Everything in this first column, those alkaline metals, and then you've got, we've got the nitrogen family, the oxygen family, the noble gases. They all have similar characteristics. So as we're looking at it, everything here gets more explosive. This is a little less explosive, but the other thing is this number up here tells me how many valence electrons there are. So if you do the electron dot diagram, I can tell you that anything in this column is going to have 1 dot on this electron dot diagram. Anything in column 2 is going to have 2. We're going to pretend the transition metals don't exist because we're not going to get into those till you get to chemistry. And then from here on out, just pretend that 10 spot isn't there. Anything in group 13 has 3 valence electrons. Anything in group 14 has 4. Anything in group 15 has 5. Anything in group 16 has 6 valence electrons. Anything in group 17 has 7. And the noble gases all have 8. So all you have to do is look up here to see for an electron dot diagram. So if I wanted to create an electron dot diagram of neon, it's in group 18, it has 8 dots. If I want to do carbon, it's in group 14, it has 4 dots. If I want to do lithium, it's in group 1, it has 1 dot. So ionic bonds are metals from the left side bonding with nonmetals from the right side. And they are very strong because you formed an ion. In other words, if I give away 2 electrons, I now have a +2 charge. And then if there's something, so let's say we're talking magnesium, it gives away 2 electrons because it has 2 in its outermost shell. But let's go to group 16, and let's say we have oxygen. It only needs 2 more electrons to get to 8. So it's going to pull in those 2 electrons that were given away by magnesium, and what you end up with is oxygen has 2 extra negative charges, so it's got a -2 charge. Well, think about it. Anything that balances out to 0 is neutral, right? So now we've got magnesium with a +2 charge, oxygen with a -2 charge, and you end up with magnesium oxide because those opposites, like magnets, attract, and that bond is really hard to break.
Chemists use the periodic table to organize all of the elements and their chemical properties. The periodic table is made up of horizontal rows of elements called periods that are arranged by atomic number. The vertical columns of the table are called groups and are organized by the number of electrons in their outer shells. These valence electrons determine how the atom forms chemical bonds with other atoms and how reactive it is. Each element is made up of a single type of atom. An atom has a nucleus of protons and neutrons, surrounded by rings of electrons called shells. If there are fewer than 8 valence electrons in the outer shell, the atom will be reactive and will either gain or lose the number of electrons needed to fill or empty the shell. When atoms bond with other atoms to achieve this balance, they become more stable.
Okay, so let's go into chemical bonds. Water has a bond, has slightly charged to it because oxygen happens to be a much bigger element than the two hydrogens. And so the oxygen tends to hog the electrons. They're shared. That's actually covalent. It's a shared bond. But anyway, they tend to stay over there more. So we ended up with slightly positive and slightly negative charge with water. And that's allows water to do a lot of things because of that charge. Water, methane, here's its molecule. Insulin is a crazy big molecule. Sucrose, big molecule. Hydrogen is two hydrogens together. Here's a water molecule. Here's another chain of water molecules. Here's carbon monoxide, one oxygen, mono. Carbon monoxide, two oxygen, di. Carbon dioxide. That's a little bit of covalent. If we were in class right now and doing this, I would tell you to take out the checkers and we would practice giving away and taking in electrons. If you wish to try this, the instructions are here. Grab some red and some black chips and you can actually end up with a charge. If you had 3 electrons, you would give 3 away and you'd end up with a charge of +3. If you had 5 over here and you needed to pull those 3 in, you gained 3 extra electrons and you'd have a charge of -3. That's what this is actually going through. It's kind of like sharing. So you and your friend walk past a market that sells apples for 40 cents each and pears for 50 cents each. You have 45 cents and want an apple, but apples only cost 40 cents, right? So you're okay. Your friend has 45 cents but wants a pear. He's short 5 cents. So you realize that if you give your friend a nickel, she would have the 50 cents, then buy the pear. You will have 40 cents left to buy your apple. Transferring the nickel gets you both what you want. Your actions model kind of like an ionic bond. In a simple way, it's what happens between atoms. This one doesn't need all of its electrons because it really wants to get rid of that outer shell with maybe 2 or 3 or 1 and get down to the one that's more stable. It would rather have an ionic charge and have a stable full shell than to have exactly the number of electrons to balance out protons, and that's an ion. So, rule of thumb, we're going to go through this again, but this is where you find it if you need to look for it in the notes. Electron transfer. Atoms with fewer than 4 valence electrons will transfer or give away electrons to atoms that have more than 4 valence electrons. Remember, atoms are stable with 8 electrons, the noble gas state. Ion, then, is an atom or group of atoms that has an electric charge. An atom loses an electron, it loses a negative charge, so it becomes a positive ion. It's actually called a cation. And an atom that gains an electron, it gains a negative charge and becomes negative. It's actually called an anion. So, 2 atoms are walking together. I'm about to lose an electron. Are you sure? I'm positive. Okay, this is a bad science joke because right now they're both neutral. But as soon as this one gives away an electron, it gained a positive charge. This one was really close and only needed 1, so it gave away. This one gave away and this one took it, so this one became negative. And now they're going to be stuck together forever because a 1 plus charge and a 1 minus charge sticks together because they become neutral. Remember, we did electron dot diagrams. Electron dot diagrams are just the element symbol, and then you go and look. If it's in group 1, it's going to have 1 dot. If it's in group 2, like beryllium, it's going to have 2 dots, and boron in group 13 has 3, and carbon in 14 has 4, and nitrogen in 15 has 5, oxygen in 16 has 6, fluorine in 17 has 7, and neon, noble gas, has 8. And that's a quick review of electron dot diagrams. If you didn't do that, you might want to go back and do that. So, Group 1 gives away 1. Group 17 has 7 valence electrons. It only needs to take in 1. Anything in Group 1 reacts violently with Group 17. Anything in Group 2 has to give away 2. Anything in 16 needs to pull into. They react pretty strongly, but not quite as vigorously as 1 and 17. And so forth over 13 with 15. And they can then do combinations of anything that make up those 3, which we will get to. All right, this is simple subtraction. You should have grabbed a sheet in class. This is also available on a PDF if you want to print it out at home. So if you don't have it, pause the video and then come back and we'll get started. Okay, hopefully you've grabbed your video. This is simple subtraction. If I have 4 positive protons, but I have 6 negative electrons. What's my charge? Well, 4 minus 6 is negative 2. 3 positive protons, 3 negative electrons. 3 minus 3 is 0, or no charge. 9 positive protons, 10 negative electrons. 9 minus 10 is negative 1 charge. 17 positive protons minus 18 negative electrons is a 1 minus charge. And actually we say it that way. We actually say 1 minus or 2 plus or whatever. We actually say the charge after. 4 positive, 3 negative. 4 minus 3 is a 1 plus charge. 8 positive minus 6 negative is a 2 plus charge. This is simple. You should go through. You should be able to do that math. Make sure you fill this out. It's good to do this on paper, and then there'll be an electronic version that you need to go ahead and do. So, some general rules about ionic bonds. A bond where an electron has been transferred from one atom to another is an ionic bond. When atoms give up negative electrons, it becomes a positive charge. It got rid of extra negatives, therefore it's positive. And that is called a cation. Good test question. You need to know that positive ions are cations. When an atom gets a negative electron, it becomes negatively charged. When it pulls in extra negative electrons, it's negative, and that's called an anion. I always think of it this way. Cations have a T, which is like the plus. Anion is the anti-positive, so it's the negative. So positive charges are drawn to negative charges. Ions tend to balance out charges to 0. So ionic bonds tend to become neutral. That's why they're stable and they're hard to break apart. These are the basic instructions for the bottom part of this Impossible Ions worksheet. So let's go through it. So this first column, electron dot, pretty straightforward. Draw an electron dot diagram for the atoms listed. Is it a giver or taker? So in other words, is it going to give away electrons or take in electrons? The general rule is if you have more than 4 electrons, it's going to take in electrons to get to 8. So if you have 5, you only need 3 more. 5 plus 3 is 8. That makes me stable. So I've taken in 3 extra electrons. I now have a negative charge of 3. If I have less than 4 electrons, I tend to give away until my outer so that the outer shell below it is full. So if you have 2 in your outer shell and give 2 away, you go down to 0 electrons in that outermost shell, and the one below it now is full. So if I give away 2, I now have a plus 2 charge because I have 2 extra protons than I do electrons. So net charge, here is the rule of thumb. If you take in 1 electron, you have a net charge of -1. If you take in 2 electrons, it's -2. If you take in 3 electrons, it's -3. If you give away 3 electrons, it's a 3 plus charge. If you give away 2 electrons, it's a 2 plus charge. If you give away 1 electron, it's a 1 plus charge. But if your outermost shell is full with 2 if you're helium or 8 for everything else, you are a noble gas. You have no charge. You are not going to give. You are not going to take. You are super happy and stable. That's all you need to do. So sodium. Sodium is Na. Sodium is in group 1. So here's my electron dot diagram. So I have Na with 1 dot. Now, if I have less than 4, I'm going to give them away. So it's a giver. So you just write a G there. How many did I give away? I gave away 1. If I give them away, it's positive. So I have a 1 plus charge. If I have a charge here, if this number is anything other than 0, I have in fact formed an ion. You're going to now go ahead and do that all the way through argon. So magnesium, your electron dot diagram is Mg. It is in group 2, so therefore it has 2 valence electrons. If I have less than 4, I have 2. I'm going to give them away. So now my charge is going to be 2 plus, and since I have a charge, I have formed an ion. What you're going to do is now get this done. Make sure you finish off that worksheet. Come back and look at the rules. Watch the video if you need. Ask me questions. Make sure you've told me that this is complete. And then coming up, you're going to want to keep this sheet to use on the test as reference and use it to submit your assignment called Impossible Ions that's through Schoology.